Earth Explorers, this is geologist Anderson. I'm about to take you on a tour of the 6 geological sites the United States Geological Society would like you to investigate as part of your mission. Our first stop will be Mount St. Helens. Mount St. Helens is located in Washington State and is the most active volcano in the Cascade Range. According to scientists, it is the most likely of the U.S. volcanoes to erupt in the future. Mount St. Helens has produced both violent explosive eruptions of volcanic tephra and relatively quiet outpourings of lava. But why does it look like there is a crater that's been formed on the top of this mountain? That may be something you want to investigate. Based upon detailed chemical analysis of the eruptive products from each stage of Mount St. Helens volcanism, scientists deduced that the volcano's magmatic system has evolved from relatively simple to more complex as the volcano has matured. You may want to explore its magmatic properties to learn more about this volcanic system. Earth Explorers, it's up to you to determine what processes cause Mount St. Helens to form, what type of volcano it is, and any possible hazards it poses. The next stop on our tour is the San Andreas Fault. The presence of the San Andreas Fault was brought dramatically to the world's attention on April 18, 1906, when sudden displacement along the fault produced the Great San Francisco Earthquake and fire. This earthquake, however, was but one of many that have resulted along the fault throughout its life of about 15 to 20 million years. Literally thousands of small earthquakes occur in California each year, providing scientists with clear indications of places where faults cut the Earth's crust. Blocks on opposite sides of the San Andreas Fault move horizontally. If a person stood on one side of the fault and looked across it, the block on the opposite would appear to have moved to the right. Sudden offset that initiates a great earthquake occurs on only one section of the fault at a time. Total offset accumulates throughout time in an uneven fashion, primarily by movement on one first and then the other section of the fault. The sections that produce great earthquakes remain locked and quiet over 100 or more years while strain is building up, so we have a buildup of pressure. Earth Explorers, why does this fault exist? What type of fault is it? And what dangers does it pose to the people of California? The third stop on our tour are the Hawaiian Islands. Hawaii is the home of Kilauea, one of the most active volcanoes on Earth. Kilauea is the youngest and southeasternmost volcano on the Big Island of Hawaii. Topographically, Kilauea appears as only a bulge on the southeastern flank of Mauna Loa. However, research over the past few decades shows clearly that Kilauea has its own magma plumbing system, extending to the surface from more than 60 kilometers deep in the earth. Kilauea is the home of Pele, the volcano goddess. Hawaiian chants and oral traditions tell in veiled form of many eruptions fomented by angry Pele. The caldera was the site of nearly continuous activity during the 19th century and the early part of this century. Since 1952, there have been 34 eruptions, and since January 1983, eruptive activity has been continuous along the East Rift Zone. All told, Kilauea ranks among the world's most active volcanoes and may even be on top of the list. Now that we've toured Hawaii, let's take a trip to the Himalayas. The Himalayas stretch across the northeastern portion of India. They cover approximately 1,500 miles and pass through the nations of India, Pakistan, Afghanistan, China, Bhutan, and Nepal. The Himalayan range is made up of the 3 parallel ranges often referred to as the Greater Himalayas, the Lesser Himalayas, and the Outer Himalayas. Mount Everest at 29,029 feet, which is 8,848 meters, is not the only highest peak in the Himalayas, but the highest peak on the entire planet. The Himalayas are the 3rd largest deposit of ice and snow in the world, after Antarctica and the Arctic. There are approximately 15,000 glaciers located throughout the range. Lots of exploring that needs to happen here in the Himalayas to really discover what has happened here in the past and in the present. Now that we've taken a quick glimpse of the Himalayas, a large range above land, let's take a closer look at the ranges that are below the surface in the ocean. Let's travel to the Mid-Atlantic Ridge. The Mid-Atlantic Ridge is a mid-ocean ridge located along the floor of the Atlantic Ocean and is part of the longest mountain range in the world. It separates the Eurasian Plate and North American Plate in the North Atlantic and the African Plate from the South American Plate in the South Atlantic. Although the Mid-Atlantic Ridge is mostly an underwater feature, portions of it have enough elevation to extend above sea level. The section of the ridge, which includes the island of Iceland, is one such example. If you're looking for the Mid-Atlantic Ridge on this map, take a close look at the boundaries. This line represents the Mid-Atlantic Ridge through the Atlantic Ocean. As you explore the Mid-Atlantic Ridge, take a closer look at the deep ocean features. I think that will give you more of an idea of what's happening at this feature and give you some observable data to help you really connect the pieces. Our sixth and final stop is the East African Rift System. The East African Rift System is one of the most extensive rifts on the Earth's surface, extending roughly 4,000 miles and stretching 30 to 40 miles wide. The system consists of two branches. The main branch, the Eastern Rift Valley, which is also called the Great Rift Valley or the Rift Valley, it extends along the entire length of the system. I'm going to have you do some more research on your own. I want you to figure out how far does this Rift Valley actually extend? What is happening at this Rift Valley? And what does that tell us about the features of plates that are on this Earth? Get exploring, Earth Explorers. There's a lot to be discovered.